Right. Hello, welcome. This is no longer business. This is the physics unit 2 starting video. Now if you're watching this in the way I've done it and recorded it and uploaded it, this is actually the last chapter in the AQA book. However, I'm going to be rebellious and do it first. So the first one we're going to do is called Diffraction Grating. Oh, Diffraction Grating, sorry. Oh, speaker would help. So, Diffraction Grating, well, what is it? Well, if you don't know, you can check my other videos, but basically Diffraction Grating is a more convenient way and is very similar to Young's double slits, and it shows that light is actually behaves like a wave as well as behaving like a particle, but it's more the wave. Now, in a Young slit, you have the single slit, and then the double slit, and then you have the screen. Whereas this, you just have. I'm going to draw the basic, what it looks like from the outside, and then I'll draw an enlarged picture, and we'll go from the equation, and we'll show you how to work the rest of it out. So, say this is your piece of card you've got. I know it's not very good, but you've got a box here of light, and you send a beam through here, and then you've got this. However, that has got very fine slits there, and you get a zero order beam. You get a first order. So the one with green around it. Oh, right. Let me draw them orders again, just so it's a bit clearer on the camera for you. So your green is your zero order beam. That should come straight out of your slits, and then you've got your first order beam, which is the blue one. And the first order is the same on each side for the degrees. And then I'm only going to draw 2 orders. We normally have about 3 or 4. 5 is generally the maximum, but you only see about 3. So they're your third order. Now, there's these parts here, there's no light, there's no light, there's no light. That's because the waves are 180 degrees out of phase, and that means that they are destructively interfering. So hopefully you've got that there. Just give you a moment to copy that down. So as I said, the thing at the back is the light box. The thing that the arrow is pointing to is the slits, and it's on the piece of card, which is showing the zero order and first order and second order beams. Now, if we enlarge this slit bit, we get something that looks like this. Oh, sorry. Yeah, I'll do it in red actually, just because I thought I had a black then. So these are the slits. They're very enlarged. These are thousands of them per millimetre. So as you can tell, this is greatly enlarged. So here you've got the slits. I know that S, oh, I'll explain what S and stuff is in a minute. So these are the beams coming in, and obviously they're going to be a lot wider than that in comparison to the slits, but this is just what's going through. And then because of diffraction, they get moved down, they all get pointed in the same direction, and then you've got theta, which is the difference between the two beams, and it's the same for each beam as you go down, so it should be theta as well. And this allows us to come up with the equation d sine theta equals n y. Now, I don't know if you can see that, but d is the diffraction grating. So say, diffraction spacing. So that's the spacing of the diffractions. So like these, the spacing between that. Theta is obviously theta there. N is the order, and lambda is the wavelength. That's your main part. You've got a few orders and things you need to be aware of. Sorry, just let me get my book. Just so there's one equation that I need to be sure of before I explain it. The maximum number of orders. Yeah, beautiful. I thought it was just making sure. Okay, so you've got a couple of. So that's your main equation there. You can derive the theta from that by dividing both sides by d. So sine theta equals ny n lambda over d. So that's your theta equation. And then you've got this. The d is not always given to you. What they tend to do is they say, oh well, we've got 900 lines per millimetre. That's not a d. That's just telling you there's 900 lines per millimetre. It's not telling you the spacing. So you use this equation. Equals 1 over d. N is a number of lines. The number of lines per metre. So if you've got 900 lines per millimetre, you times it by 1,000 to get the lines in metres, and then you divide that. So that, say 900 times 1,000. Sorry, just work that out. 900 times 1,000. 1, 2, 3, and then that gets you 900,000 lines per metre equals 1 over d. Now to get d, what you do is you swap them two around. So 1 over 9,000 equals d. 900,000 equals d. And then that gets you your diffraction spacing. Now, you may get asked, as we talked about before, we talked about the maximum number of orders. Now, we haven't worked out the maximum number of orders yet. There could be 6, there could be 7, there could be 800. We don't know. There's basically 800 though. So, hopefully we've got all these worked out and you've seen how I've done that. However, what we're going to do next is work out the maximum number of orders you could possibly have for this. So, maximum number of orders. I'm just going to write maximum number. So, maximum. You'd never guess where I came up from that. Maximum equals d over lambda. That's just how it is. That is the formula that's given in the book. I was just checking it before, making sure d and lambda were that way round, and they were. So d is the spacing, and y is the lambda. Sorry, is the wavelength. And so that gets you your equation for that section. That's pretty much it on diffraction grating. There's not much more to it than that. You might get asked about the spectras, but I think the only thing you need to know about that is the continuous spectra is the spectrum of light from a filament lamp, which is a continuous spectrum of colour from deep violet to deep red. And to be honest, I've never seen an exam question, and I've done all the exam papers from 2009, and I've not seen one that asks about the light spectra or the light absorption spectra. All you need to know is, well, yeah, the spectras and what colours the fringes are, they come more on the Young's fringes than the diffraction grating. All you really need to know for this is the formulas you need to use. The two ones that might catch you out is work out D and the maximum number of orders. They're the only two ones I'd watch out for. You're given the diffraction grating equation of d sine theta equals ny in the exam on the exam formula sheet. However, you can just rearrange it to get the sine theta divided both sides by d. So as I said before, the only ones you need to watch out for is n equals 1 over d and the maximum number of orders. If you have any questions at all, please feel free to just comment on the video. Obviously don't be an idiot and comment on Will's an idiot, or we can do other things, and he's an idiot. So, you know, just be careful of that. Well, hopefully you got Diffraction Grating, and we'll see you in the next video.